Okay, so I saw somebody posted a question on Facebook asking if there was a difference in, I guess, in their 100-yard zero based off of the angle that they're shooting. In the particular question, they were shooting 100 yards line of sight, and they had a 50-foot elevation above their target, and they were wondering if their zero would change once they moved to flat ground. So I'm going to just do a quick little explanation of how all of this stuff works. Okay, so a couple things. I've got a little dry erase board here. When considering rifle shooting, you have a couple different things. You have the line of sight, which I'm going to draw as this dotted line, and I'm kind of looking at the screen on my phone while I'm drawing this, so bear with me here. And that's going into a bullseye, and that's from the scope of the rifle. Okay, then we have the rifle itself, and I'm going to put it at a little bit of an angle so that I can exaggerate this for the picture, so on and so forth. And then I'm going to draw a straight line, which this is going to be the angle of departure. Okay, then I'm going to draw a curved line, which is going to be the path of the bullet. So we've got three separate lines here. We have the angle of departure, we have the line of sight, and then we have the path of the bullet. So those are going to be curved. The bullet actually at 100 yards should have a slight rise over the zero, over your line of sight, and it's going to fall back into 100 yards, and everything after 100 yards, that bullet's going to be falling. So we can also get measurements at different distances. So if this is 100 yards and this is 200 yards, we know that the difference between the center of our line of sight and the path of the bullet is going to be X amount of inches. All right, so I'll wipe all that off real quick. In this particular question, I'm going to do this in yards. We're going to draw a little triangle. Okay, so this represents the elevation. He said he was 50 feet, which is 16.3 yards. Okay, and he was shooting down to his target. His path that the bullet took was 100 yards. Okay, and so basically the way this works is the bullet is going to drop, or the gravity has an effect on the bullet parallel to the surface of the earth. Okay, so gravity is pulling straight down this way. So when you're shooting flat, the pull of gravity is perpendicular to the path of the bullet, but it's not the case when you're shooting at an angle. All right, so we've got 100 yards, and so we're going to use the old Pythagorean theorem, or you could take the cosine of this angle here and it would give you this distance. But for a 100-yard shot, we're going to take 100 squared, which is going to give us a number of 10,000. Okay, and then we're going to take 16.3 squared, which is going to give us 265. Okay, and a squared plus b squared is equal to c squared. So if we take 10,000 minus 265, that's going to give us a number. And dang, hang on a second, I didn't have that written down. Anyway, and we take the square root of that number, so that's going to give us x. Okay, and when we take the square root of x, it's going to give us a number of 98.66. So in the original post, the question was, is my zero going to change? Well, the actual question is there a difference in bullet drop from 100 yards, which is the path that you're shooting, but gravity is only having the effect on that bullet, which would be the same as a 98.66 yard shot. In which case, for a 223 or a 5.56 shooting a 55 grain bullet, there's going to be no difference in impact. But there is a little bit of a difference here, or this is a thing. Somebody said that no, the bullet path is still going 100 yards, so there's not going to be a change. Well, that's kind of false, because we can change these numbers a little bit. And we'll do another triangle, and we'll call, let's say the shot is a 400-yard shot, okay? And let's say the elevation is 100 yards, okay? So 100-yard shot, or 400 yard shot, 100 yards above your target. So if we take the 100 squared, that's going to give us that 10,000 number that we had before. If we take 400 squared, or yeah, if we square 400, it's going to give us 160,000. So we take 160,000 minus 10,000. That gives us 150,000. All right, and if I take the square root of 150,000, that's going to give me a number of 387. Okay, so essentially you're taking a 400-yard shot downhill, so you would aim as if you're taking a 387-yard shot. All right, now it's still not that big of a difference, but that's enough with some calibers to really cause an issue if you're trying to shoot an animal or hit a smaller target. But let's do something really big and do something really drastic. And we're going to, and this is not to scale, we're going to take that same 400-yard shot, which we know the square root of 400 yards is 160,000. Okay, and then we're going to say we're 350 yards elevated above our target. Okay, and this is a right angle, by the way, in all of these drawings. Okay, and if we square that, I'm going to see 122,500. Okay, so 160,000 minus 122,500 gives us a number of 37,500. Okay, and if I again take that, do the square root of 37,500, that's going to give me a number of 193.6. All right, and that's going to be yards. So you would be taking a 400-yard shot, but you would be holding for elevation of a 193-yard target. Okay, so hopefully that makes sense to everybody. And I don't know if you guys have any more questions. Feel free to message me about it. But a lot of guys that hunt in the mountains or do a lot of high angle shooting, they have what's called a cosine indicator on the mounted to the side of their gun or the side of their scope, and they can look at the target and it will tell them what percentage of their line of sight they should hold. So if it's a 400-yard shot and they look at the angle and it says 75%, then they're going to be holding for 300 yards as opposed to 400 yards. Because in this last scenario that we did, if you were to hold for a 400-yard line of sight or bullet path shot, you would shoot way over the back of your game or animal or whatever you're shooting at, or way over the target, because you would only need the hold of a 193-yard shot. So hopefully that helps. Hopefully that clears things up for you guys.